Hey guys, how's everything going? Let's continue our journey of LeetCode. This is my preparation for my front-end position interview in June, which is from Facebook. So I take this seriously. I think that I don't think I could pass the interview, but I want to try my best to prepare for it because I want to know the distance between me and Facebook. So the top tier tech company in the world. Okay, so now let's tackle this problem 1091, shortest path in binary matrix. We're given this kind of matrix and we need to move from top left 0 0 to m to the top bottom right, and we can move uh, move the we can move in 8 direction, like yeah, diagonal or not. And the route must be, the path must be must consist of all zeros. Okay, so we're going to return the shortest path length. If it is not, we return -1. The input, okay, so the input would be something like this, so they must be squared. Okay, and the value will be 0 and 1, bigger than 1, so there's no irregular cases. So yeah, how would we solve this? So basically, if we can move only right to or bottom, we can do this like we usually do with dynamic programming, right? We just move step by step and calculate, just keep the result of row by row, one row, and then we calculate to the second row and go to the last row. But things become different because this problem enables us to move a direction. What if it go to right and go to left and go to bottom and go up? Something like a very curvy, a very complicated curves. So the dynamic programming doesn't seem to work. And actually, we have did similar questions about the chessboard. So, which the shortest path of moving a chess? Well, it's done by BFS, which means we actually, if we do some analysis about this problem, we say we start at this point, and then with one step where we can go. Where can we go? We, of course, there's only one cell here, so we can go here, and then start here where we can go. This one is already traversed, we can skip, and these two we can move. So these two can be marked with 2 steps, and then with these 2 steps, where we can go, next one is with 3 steps, and during the 3-step check, we get the final destination. So every time we can actually do the iteration, we keep track of all the cells within the certain iteration with a certain step, and check if the target is there. If we cannot move any longer, then the iteration's ended and we can return -1, right? Yeah, sure. And when we are moving our little man on the board, we first check if it is occupied or not with 1, or it is or you occupied. It is traversed or not, right? So we need actually I'll use a flag array map to store traversed cell. Visit it equals new set. We can use set. Okay. And because the grid is a square, so it can cache them in. We use a queue to store the cells of certain steps. Of course, now that steps would be 0, right? And so the problem becomes while Q is there, Q has some elements in it. Okay, we push the first one in it. Grid 0, 0, right? Top left. And also there is a regular case means if the first one is 1, we return -1. Okay, now the first element is top left, and the steps would be, of course, 1, right? We already moved 1 in it. So when the queue is not empty, we will do what? We will shift them out to pick this batch of elements and find the next batch of next round of elements and push them in, right? Because you're while, we use a while loop, and we will use another while loop to shift the elements. We actually need the ending flag by telling to tell us when to stop, right? So actually I'll push a null in it and let head while head equals q shift. So with this we can do it round by round, right? Okay, so when we get these elements, we first check if it is our target or not. If zero equals y, okay, then we can return the steps, right? Yeah, it's done. And then what we do, we need to say it's visited or not, and we can avoid pushing the visited element, so we don't need to check here. So any elements in the queue will not be accessed before. But what if there are multiple duplicated elements pushed in? Well, so still, I think we still need to check. Yeah, we still need to do the check. Okay, if it is visited, the key, okay, we need to first define a key. We use a string to keep the key. If visited, as key. If you already traversed, of course, we just continue, right? And if not, we add it to it, so means it is traversed. And now push in the next round. Don't forget to update the steps. Plus equals 1. The next round was 8 directions, right? So let I equals -1 to 1. We can use this for loop to calculate the next coordinates, but the center 0, 0 case means not moving, means stay, so we need to skip that. Now next, so now we're getting the next coordinates, right? The next would be, of course, head 0 plus I, head 1 plus j. So this is the next element. The next element, there are some possibilities. One, it may be out of this chessboard. Next one, it might be the grid might be 1, and the third, it might be already traversed. So we need to check if I'll create another function. So is valid, is available, is walkable, is available. Next. if it is available, we push it in. So Q will push next. Remember that there might be duplicating here, but it will be checked in this visited. So okay, let's create another utility. Check if a chord is valid. First, if it is out of board, or the grid is not the grid, or the grid is 1, right? Grid I j equals 1, or it is already traversed. So visited I j. No. Get key. We can, okay. We say key would be I j visited has key. Return false. Otherwise, return true. So if it is available, we'll push them in and update the steps. Yeah, I think this will work, right? And we will return -1. We return steps here. Yeah, let's run the code. Oops. Where is XY? Oh God, my bad. There's nothing called XY here. Cool, let's submit. Oh, we're getting an error, which is basic input like this. We're making a mistake, obviously. Let's try to debug within our head. Okay, we shift to the head, and then check if head is the top bottom elements, then we return steps. And if not, we check if it is already visited or not. If it is, we continue. And then we add it to visited, so it's already visited. Now let's push to the next round of element. -1 I j. Okay. If it is the sender, means it's not moving, we continue. So the next would be I and j, right? This is the next element, and if it is available, we push it in. So the available is available means, what does it mean? Oh, j, God. Cool. We're accepted. Now let's analyze the time complexity. Wow, this actually, for steps, if we going so technically for worst case, actually every time we only add one element, so that actually it's I'm not I don't know the exact, but it depends on the input. So the worst case, it means every time we will only check one element. Well, so that would be length n, right? Space we use a set which will I and j, which is the coordinate. So yeah, it should be O n squared. But we're slow, right? We use 30%, only faster than 30%. So how could we improve? Well, actually, we noticed that one thing. The chessboard problem we did before, please search on my channel. We were using this visited set, but actually we already had a grid, right? The input is actually a grid, so maybe we can reuse that. We're not told to not touch the grid, so we're okay to use the grid. It means this set might not be necessary. We could remove it. We can use the original one, right? If we use the original one, what will change? Well, we can check if we can set it to 1, like a grid, head 0, head 1, set it to 1, right? And then visited has key, visited has, let me continue, which means this. So it's still, well, visited has this, so it will become a grid like this. This will be I and j. Let's run the code. Invalid left hand side. Wait a minute. Oh, okay. So there is no need of this. Smart. Failed. What? Okay, the key is not necessary. If it is 1, we continue and we set it to 1. And the next one is this. Check the availability and move it. I think there seems to be no problem. Grid, yeah. So what's the problem? I'll just batch down. I'll log the steps and queue. Why there is no log? Yes. 1. Available I is in the board, or it is occupied. For this, it is occupied, but the next one is not. Log check ij grid ij. Actually, this availability is not actually called at all. Huh? Oh, my bad. I use a God. Here is what happened. I used assignment to do the comparison. Of course, I'm gonna be punished. Okay, let's submit. Wow, it's better, but still not the best. So see what we could improve here. Remember that for here, we're checking a batch of we are pushing the next round of elements, but actually here there might be duplicate. We might push one element and then push another element. That will be filtered out here, but maybe we could do more aggressively. We have an assumption that all the elements in the queue would be actually be accessible, so we only push the available one. Is it available? And we'll make it unavailable to avoid that duplication. So we will set the grid next 0, next 1 equals 1. Now, actually this could be removed, right? There will be no more duplicate. It will be set to 1 once it is pushed in the queue. Run the code. Cool. Let's submit. Okay, now it's better. So actually we can improve the methods could be improved. Oh God, I'll just use the original solution and copy. We use a visit. Okay. So this is the original solution. Comment it out. And now we have in this new one, time. I think it's n square. Oh God, this should be n squared. N means the length of the grid. Okay. So space. We're actually not creating new space, right? We use a queue. For this queue, actually will be maximum for 8, right? No, oh, it's not. So actually, wow, it's actually 8 times something. Wow, the space actually doesn't change, I think. But it's much better than this one. Okay, so that's all for this problem. Hope it helps. See you next time. Bye-bye.